Welcome. Today we're going to be learning about the hinge theorem. Now, in my own words, the hinge theorem states when two triangles have two congruent sides and information on the included angle, we're able to figure out the triangle with the bigger angle and it has the longer third side. Look at this diagram here. We have a triangle. We're going to call it ABC. Its sides are 7 and 12. And its angle is 28. And look, it's the included angle right here. Now, we also have this triangle over here. And its side right here is 12. So it's congruent to BC and YZ. They're congruent. Now, this side is 7. So it's congruent to AB. So AB and ZX are congruent. So we have two congruent sides already, which is what we wanted. And we also have information on the angle. This angle is 19 degrees. Now, based on the hinge theorem, we know with a larger angle comes a larger side. So if this is 20, then this is an angle of 19. This is an angle of 28. 28 becomes 20 over here. This opens up to 20. Now, 19 cannot be above 20 because it's a smaller angle than 28. We don't know what it is right now, but we're going to look deeper into the hinge theorem. Here's our first question. Now, look at the two triangles. What do you notice about them? They have these markings on them, which means they're congruent to certain sides. So, this side here, let's change color. This side here, and this side, and this side, and this side, they're all the same length. We don't know what that length is. And now, this middle bit here, they both share it. So this is also congruent. We already have two congruent sides. Look at our criteria. Two congruent sides. We have those two congruent sets of sides. Now we're going to look for our angles and our angle measurements. We can see that 10 is bigger than 7 over here. So, because this angle is bigger than this one, we know the bigger number of these two is going to come over here to this angle. So, 26, the angle 26, goes to the side length of 10. And the angle 24, because it's smaller than 26, gets the smaller of these two numbers, which is 7. So, the length of XB is 7, and the length of ZB is 10. Now, we figured that bit out. Let's figure out what these two angles up here are, because we just have that it's 1, 2. We don't know what it is. Now, because 7 over here is 24, we know that's going to be the same. So 2 equals 24. And angle 1 equals, what is that? 26. So, we've solved our problem. The bigger angle equals the bigger side, and we've used this. The bigger angle is 26. The bigger side is 10, so they match up and go together. The smaller angle and the smaller side, so 7 and 24, they match up and become this. And now we solved it. The measure of angle 1 equals 26, and the measure of angle 2 equals 24. The length of XB is 7, and the length of ZB is 10. Thank you for joining me on this problem. See you in the next one. Okay, welcome back. We're on part 3 of the Module 2 honors assignment. So, the directions for this is write an inequality or pair of inequalities to describe the possible values of x, then solve the inequalities to find the values of x. So, we're going to look at this graph here, or these triangles, sorry, and try to figure out what x could be. We most likely won't be able to find the actual value of x, but we'll know what it's bigger than or what it's smaller than. Okay, so first we're going to start by making sure we have our two pairs of congruent sides. Here's one here, because look, it's congruent to itself. So that's how we know this line is congruent. Then we also have 8 and 8, so that's two pairs of congruent sides. Check. And we have information here on our angles. This angle's 135 and this angle's 95. So we also have our angles. Now, we can see that 10 follows the angle of 95, and we know that 135 is bigger than 95. So that means this over here has to be bigger than 10. So we're going to write that out as an inequality and solve. So 3x minus 2 is bigger than 10. So we're going to add 2 to both sides, because whatever we do to one side has to be done to the other side. So 3x is greater than 12. Now, we're going to divide both sides by 3 and come up with x is greater than 4. Okay, welcome back. This is part 5, I believe, part 4 or 5 of the honors assignment. So, this is asking us to write the inequality that represents the possible values for x. Now, I've drawn the triangle, but I haven't worked it out yet, so we're going to work it out together. Alright, so we have to make sure it follows our criteria of two congruent sides and info on our angle. Angles. Okay. Now, look here. We have 60 opens up to 18. Well, first we got to make sure we got those congruent angles here. So we have two congruent sides, and our included angle, which are these, these right here. These are our included angles. So we have info on our angles. Now we're going to start to work it out. So 60 opens up to 18, and 6x plus 12 opens up to 10. Now what do you notice about 10 and 18? 18 is bigger than 10. So that tells us 60 is also bigger than 6x plus 12. So we're going to write that as an inequality. 6x plus 12 is smaller than 60. So now we're going to solve it like we would any other x problem and try to isolate x. So we're going to subtract 12 from each side, which leaves us with 48 here and 6x here. Divide both of these by 6. Okay, so we have 6x is less than 48, and we're dividing both of these by 6. So x is less than 8. Now less than 8. Well, I mean, negative 1,000 is less than 8, so we have to figure out more than that, right? We have to make sure that our 6x plus 12, can you see? Yeah, okay. Our 6x plus 12 is always going to be greater than 0. We can't have a negative angle. We just can't. So we're going to do the same thing we did over here, subtract 12. So 6x is greater than negative 12. 12, sorry. So x is greater than negative 2. So far we have our x, and it's bigger than negative 2, but it's smaller than 8. So this is going to be our problem, or our set of inequalities that represent the possible values for x.